Hey everyone, welcome to Precalculus 1.1. This is the first lesson in all of Precalculus. We're going to start right from the beginning, section 1.1, functions and their function notation. Before we even dive into Precalculus, we need to understand one of the most important ideas in all of math, functions. You've seen them before. F of x equals x squared, y equals 2x plus 3. But what do they really mean? A function is like a machine. You put in a number, that's your input. The function does something to your input, then you get exactly one output. For example, if my function is x plus 2, and I input 2, I'm going to plug in 2 for x, then I will have 2 plus 2, my output will be 4. Be careful. If you have some arbitrary machine and you plug in 2, and let's say you get out 5 and 3, this is not a function. Your function will always have exactly one output per input. You cannot have more than one output. We usually write a function as f of x, where f is the name of the function and x is the input. The name of the function is really up to you. The name could be g of x, or h of x, or smiley face of x. It really doesn't matter, as long as you have your input and your function. For example, if we had f of x equals 2x plus 3, how would you find f of 4? Well, to find f of 4, you plug in a 4 for everywhere that there is an x in your equation. So you would have 2 times 4 plus 3, which is 8 plus 3, or 11. That means your f of 4 equals 11. This just means that when your input is 4, your output is 11. Every function has two things, a domain and a range. The domain is all possible input values, anything you can plug into the function. The range is all possible output values, anything you can get out of the function. So if I can plug in 4 and I can plug in 9, those are part of my domain. Now if I plug in 4 and I get 2 out, if I plug in 9 and I get 3 out, 2 and 3 are part of my range. For example, f of x equals the square root of x. You know that you cannot take the square root of a negative number, so your x will always have to be greater than or equal to 0. You also know that no matter what you plug in, you will never get a negative number out of this. So your y, your range, must also be greater than or equal to 0. Another example is f of x equals x squared. You can plug in any real number you would like. So x would be an element of the real numbers. As for y, if you plug in a positive number, you will get a positive number out. If you plug in a negative number, you will still get a positive number out. No matter what you plug in, you will never get a negative number. So your y values will always be greater than or equal to 0. If you're unfamiliar with this notation, this says that x is an element of, or part of, part of the set of real numbers. The set of real numbers is notated like this with an r that has 2 lines. Another way to write this would be using interval notation. You can go from negative infinity to infinity. A graph is a picture of all the ordered pairs x, f of x. For example, when f of x equals x, you can see we get this straight diagonal line. But why do we get this shape? Well, let's think about it in terms of a table. We have x and f of x. And let's plug in a value of x. Let's plug in 0. We know that f of x is equal to x. So if our input x is 0, then our f of x will also be 0, because these two things are equal. Now let's plug in x equals 1, we're going to get 1. You plug in x equals 2, we're going to get 2. So here you can see at x equals 0, our y is 0. At x equals 1, our y is 1. at x equals 2, our y is 2, so on and so forth. Now, for f of x equals x squared, let's draw a table to represent each point. We have x, and we have x squared. Let's plug in 0. 0 squared is 0. We have a point at the origin 0, 0. Let's plug in 1. 1 squared is 1, so we have a point at x equals 1, y equals 1. Let's plug in 2. 2 squared is 4, so you go right 2 and up 1, 2, 3, 4. You can see we get this kind of growing shape like that. Now if we go in the negative direction, we would have -1, and out from -1 we would get 1. -1 squared is 1. If we plugged in -2, -2 squared is 4, so we still get, we go to the left 2, we go up 1, 2, 3, 4. And you can see we get the same shape on both sides. This is to be expected from x squared as it is a parabola. It is symmetric over the y-axis. Remember how we talked about how every input value has exactly one output value? Here we have our x-axis, or our inputs, and here is our y-axis, our outputs. So let's say our input is here. We're going to get exactly one y value out of that input. Say our input is here, we're going to get exactly one y value out of that input. Now, notice that this y value is also over here at this input. This does not mean that it's not a function. Multiple inputs can have the same output. However, one input cannot have multiple outputs. On a graph, let's say we had something like this. Now, if we had an input here, you can see it not only gives us this y value, but this y value. So this is not a function. The way you can test for something like this is using the vertical line test. Draw a vertical line through the graph at any given point, and it should only ever touch the graph at one point. If it touches at more than one point, it is not a function. As you can see here, it touches at 2 points pretty consistently. This shows that it is not a function. In summary, a function takes each input and gives exactly one output value, no more than one. The domain is what you can plug into your function, and the range is what you can get out of your function. F of x is the relationship between your input value and your output value. Before I go, I have a few practice problems for you to try. Here are 3 quick problems. You can pause now, or I'll give you the answer and work in 3, 2, 1. These are the answers. Thanks for watching. My tutoring email is in the description if you would like to reach out, and I will see you next time for Precalculus 1.2.